Hello, my dear students. Welcome to one more amazing session from Infinity Land. This is Suresh, Faculty of Chemistry. How are you all doing? Please confirm. Can you all able to hear me and see me? आज हम चर्चा करने वाले हैं thermodynamics. So, welcome to NEET program. Here in the NEET examination, students, especially from those problem with the physics, na. So, thermodynamics is something related to the physics and mathematics. So, you guys naturally develop a tendency to get a fear about this chapter. Hi Betu, Radhe Radhe. And what I want to say here, at this end of the session, no doubt I'm going to take a part of it. I'm going to give you simple tricks and tips to understand thermodynamic process and various things. आज हम चर्चा करने वाले हैं thermodynamics. तो पिछले क्लास को thermochemistry डिस्कस किया, आज thermodynamics करने वाले हैं. Actually, it is supposed to be thermodynamics first and thermochemical equations next, and it is swapped. And so, while it, please attend the class throughout the session and don't drop and take a note, take a pen and paper and write a noteworthy points. And this session is especially useful for those students preparing for 11th standard and NEET examination. Those who are in the 12th standard, you have some backlogs at the 11th also, and those who are in the dropped, and you can go ahead with this thermodynamics. Definitely I can say thermodynamics gives you a question from a NEET examination. Undoubtedly, definitely one question means it is a 4 marks will be in your pocket. Definitely I can assure you that, and I am going to give you all mathematical calculations and all. Never and ever fear about mathematical calculations that you see in thermodynamics. Rather, the basic formula and the formula related questions you do it. And definitely you stick on to the NCERT, you can do the best. Okay, those who are online, please like the session, share with your friends. And before subscribe to Infinity Land NEET YouTube channel, so that all the series of lectures we are going to complete here. Total physical chemistry फिलहाल हम खत्म कर चुका, and अगले महीने में organic chemistry आने वाला है. Okay, so students, come on here in thermodynamics. Before going for the thermodynamics, I just want to bring you 2 promotional slides, and it is a surprise for you. It is a score examination. What is the score examination? India's largest scholarship exam. And this India's largest scholarship, why we conduct this and what it is. And Sri Chaitanya Academy is a unicorn in the entire education industry in India. So we want to go for hunting the bright talents like you. So in the talent hunt, it is a way a scholarship exam. Why it is India's largest scholarship exam? You know, it has, it is 2.5 crore worth of cash rewards directly will be given to the deserved students, bacho. And also 350 crore rupees of worth scholarships will be given depending upon up to 100% scholarships that you can get if various courses. Bacho, और एक चीज़ है, this examination you can write, you may be related to Sri Chaitanya or Infinity Land, or maybe you study in any other government or private institutions, still you are eligible to write this. When you write this, you know, you can write this examination offline and online. There are 2 days we are offering this examination. One is on September 28th and October 12th. Registrations are open in the description box. Link is available. You just click it and you can just go to the registration. And for September 28th examination, you can register up to, last date is going to be September 26th, and October 12th examination you can registrations open up to October 10th. And you can write online at home or you can write offline in the respective Sri Chaitanya Academy centers. For writing offline examination, you just visit the nearest Sri Chaitanya Academy and book your slot. Depending upon availability, the dates can be changed. And also, you can see the exciting things. Have you ever dreamed to go to NASA, United States of America? And it's a dream, right? So, to explore the space miracles, and it is on us. Those deserved students are going to be taken NASA, United States of America, and will give you the best. And also exciting gadgets will be given, like tablets and laptops will be gifted to you, those deserved students. Why late? Grab as many as gift you want and Description box link is available. Click it and do the best. Betu, and score examination. Any student from grade 3 to grade 11 can write this examination. Depending upon the grades, you will be given a different question papers and different modules as well. For the score also, we will be running a separate channel where we are giving a questions and answers and the training as well. Anyways, that's a different story. Let's go ahead with your NEET examination. We are in this channel right now preparing for NEET 2026. Ready for that? And in this NEET 2026, what else we need it? I want to give you NEET test series, one more promotion slide. After this, directly we go into thermodynamics. Okay, just one more minute. And what is this NEET test series? I will tell you one thing. But so if you ask any of the toppers who already cleared the NEET examination, they simply said they prepared like you. Well, they did hard work. Kya fark padta? And they did a test series. Yes, it is not only this NEET examination. If you prepare any examination, it is utmost required to understand what is your strength and where exactly you stand. For that, you need a proper assessment platform. This assessment platform is prepared by the expert faculty from the NEET examination team, from the content team, from the Infinity Lane by Sri Chaitanya, and prepared this NEET examination. And this test series gives you the based on the latest NTA examination pattern, bacho. And also, it gives you awesome simulation of real-time test taking experience. Definitely, if you take this test, definitely you will be seeing a real-time NEET examination, jo questions aapka aane wala hai. And before the examination, the same model of the questions we will be giving a training to you. It is going to be a really golden opportunity. In the description box, link is available, and you click it and you do this awesome test series. And this is designed separately for 11th and 12th and repeaters. And और एक चीज़ है, when you click it, you want to purchase it, you please enter YouTube 30 off coupon code, so that directly you will be getting 30% flat discount, बच्चों. And definitely you are going to do the NEET examination the best. Okay, all the best, and write your NEET examination with a great preparation. And moving ahead, we will discuss this thermodynamics, first law of thermodynamics, second law of thermodynamics, Gibbs free energy. These three are the major areas where you need to focus on when you study about this thermodynamics. So please, those who are on online, please like this session, share with your friends, subscribe to NEET Infinity Land YouTube channel, and let's see what you're going to learn. First law of thermodynamics, and we're going to see entropy and enthalpy, and second law of thermodynamics, Gibbs free energy and spontaneity, and thermochemical equations, and Hess law of constant heat of summation. In the previous class, we completed this, and we will be focusing on this enthalpy and first law of thermodynamics, entropy and Gibbs free energy change. And when you prepare something, you need to have a proper planning for that. Okay, assuming that you know zero, from the scratch level, I am going to explain the thermodynamics in today's class. Ready? Thumbs up and fire emoji, everybody in the live. Everybody in the live, this is a live interactive session. So I strongly encourage my students to discuss something in the live chat, so that you are going to discuss something with me, and academically spamming is prohibited here. Right? Beto, mera आवाज सुनाई दे रहा है क्या? Come on, let's see thermodynamics right from system and surroundings. आप देखने वाले हैं, right? Very good. So a quick revision. Those who already knew it, as it is a revision. Those who don't know it, and learn from here. So thermodynamics. Thermodynamics is a branch of physical chemistry which deals with the heat changes or energy changes during a process. So why heat is transferred from hotter body to colder body? Why not from the colder body to hotter body? So kind of logics we are going to discuss. So don't go into the Carnot cycle and all. This is related to the physics, and here in the chemistry we focus on the first law and enthalpy and entropy and Gibbs free energy. So this is the boundary of this question, this particular topic. What is the system? A system is the one where a thermodynamic study is done. A system is a total part of the universe which is under thermodynamic study. And what is the surrounding? And the surrounding is the one in the entire universe except the system, everything is comes to be surrounding. So the system and surrounding together is said to be universe. मैं क्या बोलना चाहता हूँ, यूनिवर्स सिस्टम सराउंडिंग मिलके होगा. जो पार्ट है यूनिवर्स में थर्मोडायनेमिक स्टडी चल रहे हैं, दैट इज कॉल्ड सिस्टम. इन द सिस्टम वी हैव थ्री टाइप्स ऑफ सिस्टम्स. One is an open system, another one is a closed system, the other one is an isolated system. So I'm expecting doubts from you, bachcho. So what is an open system? So open system is a system where you can exchange the mass as well as the energy. Just take a open cup of bowl or boiling water. Hello. And you can say a closed system where you can close it so that you can't enter any mass in it. Right, good morning, and you can exchange the heat. Let us say a water bottle is kept in the refrigerator is going to be a closed system. Once it is the closed, right? When you take a cup of coffee, hot cup of coffee in a thermo flask, you can't take this cup of coffee out of it once it is closed, and heat cannot be exchanged. That is called an isolated system. In the isolated system, neither mass and nor energy is exchanged over here, right? So we are going to discuss in these three kinds of versions. This is also called as adiabatic system. And you know, this is a boundary which is separating the system, and this is a surrounding, right? So what is a boundary? So you have a boundary is the one which physically separates a system and a surrounding. And the boundary can be an imaginary or real interface which separate the system and the surrounding, है ना? And this boundaries of two types, diathermic boundary and adiabatic boundary. Diathermic boundary can exchange the heat on the either sides, and adiabatic boundary it do not allow the heat to exchange. Beto, and let us see the state functions and the path functions. So we want to say something. What is the state function? It is a function or a property which defines the state of a system, and this depends only on initial state and the final state during a process, while the path function is a property which depend on initial as well as the final state, including the direction in which the change is taking place. That is a path function. You know, very simple thing, I just want to tell you, the path function only heat and work comes under this. The path function, it is indicated by small q and small w, while the path functions and the state functions are done by p, v, t, are called state functions, where you have to use the capital letters to include this. So small letters, only two things are there, work and heat, while the state functions except these path functions all are state functions, right? So let's see here extensive properties and intensive properties. NEET examination में simple question आपका fire किया जाएगा. Which of the following are the state functions? Which of the following are the path functions? Among the which of the following is extensive properties, and which of the following are intensive properties? Okay, so let's see here. Intensive properties are the physical properties that do not depend on the amount of the matter. Like you can say density. You take a density, a glass of pure water density is 1, a bucket of pure water density is 1, a tank of pure water density is 1. Density is the parameter which do not depend on how much water you take. That is, it is intensive property. That is intensive property. While extensive property depends, you can see it is a depend. Like you say volume, mass, these are all depends on the extensive property, and you can see here some examples: volume, mass, energy, kind of things. When extensive property taken per mole or per gram, it will become intensive property. That's very, very, very important. And you just see a trick in the NEET examination. The ratio of the extensive property is going to be intensive property. So density is equal to mass upon volume. Now, what is density here? What is density here? Density is going to be intensive property, na? And mass is an extensive property. And mass is an extensive property. So, मैं क्या बोलना चाहता हूँ? Extensive property का ratio intensive property होगा. Hi, talk boy. So, you talk only doubts. Okay, I'm expecting doubts from you. So, those who are online, please like the session. I'm expecting you guys to do that. Okay, Beto? Right, let us talk about the intensive properties. These are the list of the intensive properties. Let's see here chemical potential. What is the chemical potential? आपका जो E0 value है ना, electrochemistry में C का है ना. And you can see concentration, जो molality, density, and ductility, elasticity, hardness, melting point and boiling point, pressure, specific heat capacity. These are all the things comes under the intensive property. Definition का हिसाब से एक बार analyze करो. And extensive property, energy, entropy, Gibbs free energy, length, mass, particle number, volume, and charge, and everything. And also we have the physical state of a system. You have two types of physical states. One is a homogeneous system, another one is a heterogeneous system. Homogeneous system, it is a system without surface separating. So, this is the technical terminology can give you a little confusion, है ना? No confusion. I am going to give you the simplest way. बच्चों, homogeneous system जिस system में सब का सब components एक ही physical state में होगा. I mean to say all these particles or the components in a system in the same phase is said to be a homogeneous system. और अलग phase होना तो that is called heterogeneous system. You take water and ethyl alcohol, it is going to be a homogeneous system. You take a water and oil, it is going to be heterogeneous system. समझ में आ रहा है क्या? Right. So let's go into the more details about this. And thermodynamic process. Thermodynamics आप कहना चाहता हो क्या? So thermodynamics tells us whether the process takes place. A process में क्या होगा? A change. That could be a physical change, that could be a chemical change. So let us talk about the physical change. You take a cube of ice, keep it in the table, it will melt, become a liquid. So I mean to say H2O, which is in the solid state, is converting into H2O in the liquid state. So it is going to absorb heat. It is going to absorb heat. So, how much ice is converted to water by absorbing how much heat? That is the major role of the thermodynamics. So, a system, it changes from one state to another state. The process is called as the operation is called as a thermodynamic process. You have various types of thermodynamic process beta. So, we are going to discuss this and we'll take the first law of thermodynamics and you apply this same thing into the various thermodynamic process. So, let us say adiabatic process, a process with no heat transfer takes in and out of the system. इसमें change in the temperature 0 होगा. Change in the heat is going to be 0 होगा. That is called adiabatic process. Adiabatic process. I will rewrite this. Okay, that is going to be dq is going to be, that is going to be dq is going to be 0. Change in the heat of the system is going to be 0. Right? And talking about isochoric process, the process taking place at a constant volume is called an isochoric process. We can say dV is equal to 0. Change in the volume is going to be 0. So these are the noteworthy points, my dear students. Write these points and prepare an awesome thermodynamics. So if you are very good at fundamentals, you can do thermodynamics nicely. Otherwise what happens na, thermodynamics is going to be a rough journey. Okay, आपको दिक्कत हो जाएगा, fundamentals में strong होने का तैयार रखो. And isobaric process, जिस process में pressure हमेशा constant होता, so that is called dP is equal to 0. That is called dP is equal to 0. Right? right? And isothermal process, जिस process में temperature हमेशा constant होता, so this is going to be dt is equal to 0. Now there is a confusion between this and this, right? And dt is equal to 0 means during this process heat may be absorbed or emitted, so that if it is absorbed or emitted temperature में variation आना चाहिए. So to avoid that, the system is thermally conducted so that its temperature is always constant. So in order to achieve this isothermal process, we keep the reaction container or experiment vessel in a heat sink, so that you can keep into the water bath, so that you will be getting temperature always constant. So moving ahead, here thermodynamic process में isothermal process T constant होगा बेटा, and isobaric process pressure constant होगा, isochoric process volume constant होगा, adiabatic process dq heat is going to be constant बच्चों, and the process in which the system returns to its original state after series of successive transformation is called cyclic process. I mean to say, a system undergoes n number of changes. A turns into the B, B turns into the C, C turns into the D, D turns to the A again. So this is called as a cyclic process. This cyclic process experiments and PV graphs are very important for NEET examination. I am going to take you there. So mind it, whenever cyclic process is there, you are going to say change in internal energy is going to be 0. Work may or may not be equal to 0. That is very important. Key points, whenever the terminologies comes now, you have to think this is the important. And as long as the temperature is constant, okay, and internal energy is also going to be constant, because internal energy is directly proportional to the kinetic energy is directly proportional to the temperature. जब तक temperature constant होगा, kinetic energy constant होगा. जब तक kinetic energy constant है, जो internal energy of the system is going to be constant. Okay, so these are the simple tricks you will understand and you will use in the thermodynamic operations, बच्चों. And moving ahead, reversible and irreversible process. Reversible and irreversible process. Now let me talk about this irreversible process. When a gas is expanded from V1 to V2, so this is the V1. If the pressure of the gas is more than the pressure of the atmosphere, so it is going to be expand simply in one step to expand. So state V1 to V2 it is expanded and the piston never comes back, and this process has only two steps, initial and final, and this is called irreversible process. The process which takes place in a single step is called irreversible process. While what is the reversible process? In this reversible process, it takes place in infinitesimal small number of steps is called reversible process, and in that you will be having initial stage and the final stage. बीच में multiple steps होगा, हर step में system खुद equilibrium experience करता. That is what is called as an irreversible process. Dear children, NEET examination में simple, you may be given a question or a numerical. In theory it becomes like which of the following is true. Gone. Should be very clear about the theory part and the fundamental parts. Okay? So you are going to experience equilibrium in every step in the reversible process. You are going to experience equilibrium only in the initial step and the final step for the irreversible process. That is the noteworthy points. Those who are online, please like this session. Please like this session. I want to see the number of likes as goes on. Okay. Let's see main process in the chemical thermodynamics. So you have to take this main process. जो भी process आपका आना वाला है NEET examination में, there are two things you need to focus. Either isobaric process and isothermal process together, or isochoric process and isothermal process together. So one process alone you can write, this is dP, dt, dV. Sometimes the question can be framed in such a way that two process together. So isobaric, isothermal process, both pressure and temperature kept constant, while isochoric and isothermal process, volume and temperature दोनों भी constant होगा. All chemical reactions takes place under these two conditions. So this is the noteworthy point. So most of the cases NEET examination focus here only these kind of processes. So let's talk about derivative quantities. You have process functions and the state functions. The process functions are called as path functions. And this is the state functions as discussed. Hi Queen, hello. And let's see more details about this. Now PV work. What is the PV work? You can say work is all of various types in the thermodynamics, in which we have to take a PV work at a pressure volume work has to be taken into the consideration. When the piston is taken in the cylinder and some gas is given, and this gas has a pressure greater than the atmospheric pressure, so that it is going to change from V1 state to the V2 state. This is called the change in the volume, that is called as dV. So if you apply in physics and do all these derivations, simple thing I would like to say, for irreversible process, it is said to be work done is equal to minus P external and delta V. Okay, and what is delta V? Delta V stands here V2 minus V1. So this is a reversible isothermal process because the heat can go in and work is done in this way. So this process is called as an isothermal process. And it is an irreversible expansion. So pressure is atmosphere and change in the volume is liter. Atmosphere is the unit for this. Hi Komal, how are you? It is going to be 1 liter atmosphere is equal to 101.3 joules. This conversion is important, 101.3 joules. And moving ahead, so sign conventions, work done is taken a positive if work is done on the system. Work done is negative if work is done by the system. If heat goes into the system, it is said to be Q is positive. If heat is going out of the system, you are going to see. So work done, this is a system. Okay, work done on the system, it is going to be W is going to be positive. Okay, if heat is given, so Q is going to be positive quantity. If work done by the system, W is going to be negative, and heat released by the system, Q is going to be negative. My dear students, there is a conflict, something goes wrong in physics and chemistry. In the physics, W is going to be positive when the work done by the system. W is going to be negative if work is done on the system. But according to IUPAC and CBSE or NTA NEET examination pattern, use these conventions. If work is done on the system, W is going to be positive. If work is done by the system, W is going to be negative. We follow these conventions suggested by IUPAC in chemistry. So we follow this only. So the perception is different. Everybody follow this. Let us say this is a question where I am going to explain you when 1 mole of an ideal gas in 10 liter container at 1 atm is allowed to enter into the evacuated bulb and capacity of 100 liters. So we know that what is the work done. So when 1 mole of gas expands from 1 liter to, so this is another question. So let me do this question A. If it is a vacuum, external pressure is going to be 0, Komal. So that work done is going to be 0. So always 0, because W is equal to minus P external delta V. So for the vacuum, I just want to say evacuated P external, vacuum कुछ pressure exert नहीं करते हैं ना, so that is going to be 0, so work done is going to be 0. समझ में आ रहे क्या? Are you getting or not? Clear? And you or with a lot of enthusiasm, you guys engage with these numbers and leave the logic, and you end up with a wrong option in the question. So options are given in such a way that you are going to direct to the wrong option. Samjhe? So moving ahead, when 1 mole of yellow color, when 1 mole of gas expands from 1 liter to 5 liter, so V1 is equal to 1 liter beta, V2 is equal to 5 liter beta. We use that W is equal to P minus delta V. So external pressure is going to be 1 mole here, atmospheric pressure P external यहाँ पर 1 होगा. So that 1 into V2 minus V1, 5 minus 1 is equal to 4 liter atmosphere. But when you see this 4 liter atmosphere, answer में नहीं देखता. अभी क्या करूँ मैं? Komal, Queen, Takbhai and Beto, you tell me. You have to convert this into joules, right? So 4 liter atmosphere, 1 liter atmosphere is equal to 101.3 joules. समझे? So multiply this with, so W is equal to minus expansion now, it is going to be minus. So 4 into 101.3 joules. So always try to solve the questions in SI units. So check the options. Based on the options you can do it. But so here I can say question, find the work done. I am going to give you the examples. Solve the examples along with me and you can do it. And how many of you can solve? I want you to give the answer in the chat box. The question is given. Find the work done when 18 milliliters of the water is getting vaporized at 373 Kelvin. It is a very famous question in an open vessel. So P external is going to be 1 atm. 18 grams means 1 mole. 18 grams means 1 mole. Because 18 grams, 18 ml is equal to 18 milliliters. Because density of water is going to be 1. So I just want to say, we know that PV is equal to nRT. PV is equal to nRT. So PV is equal to number of moles is 1, R is equal to 0.0821, T is equal to 373 Kelvin. 373 Kelvin. So that PV is equal to V 30 liters mila, work done is equal to P delta V. So when you see the P delta V, P is external, it is going to be 1 atm, and delta V 30 minus volume of the gas. So I mean to say minus 1 into 30, 30 liter atmosphere. So 30 liter atmosphere is going to be minus 30 into 101.3 joules. Bas, that is your answer. So this is very, very important model of the questions there you can see. Right? So those students who are online, please like the button. I am going to give you some more examples. So I say when the system heat is given into the system, Q is equal to positive, and Q is going out of the system, Q is going to be negative. And you see, Q is out of the system, W, work is done by the system. So work is going out. So work done is going to be negative, and work is going into the system. I mean to say work is done on the system, it is going to be positive. So that is very, very important. If the system loses heat na, so surrounding का heat बढ़ जाता, system का heat कम होना चाहिए. So that is plus and minus is a game changer for the thermodynamics. Moving ahead, and here difference between the heat and work, we discussed this and first law of thermodynamics. What is the meaning of the first law of thermodynamics? Energy conservation law. It says that if a certain quantity of energy, heat means energy in thermodynamics, is disappeared, same quantity of another type of energy should be appeared. Therefore, I want to say energy neither be created nor be destroyed. Betu, work done in 18 ml of water vaporized, it is going to be exactly exactly you can say. Right, your answer is appreciated. Now let me say, if some quantity of energy is disappeared, equal quantity of work should be done. That is, otherwise we can say, so work and heat are interconvertible, and it is impossible to construct a machine which can work continuously. I mean to say, a perpetuate machine. So it is impossible to construct a perpetuate machine which can work continuous, which cannot work, which can work without supply of continuous energy. So जब तक आप energy देते रहते हैं ना, तब तक ये machine चलते रहते हैं. If you stop giving energy ना, it eventually stop. So it will work for some time, means maybe its momentum it can do it. Fine. So it is impossible to construct a machine which can work continuously without continuous supply of energy. That is a known version of this thermodynamics first law. लेकिन mathematics में कैसे करना? Suppose we can say here, this is a system बच्चों. इसका पहला U1 is initial state of internal energy. What is internal energy? Sum of all kinds of energy is called internal energy. इसका कुछ heat दिया जाएगा, कुछ काम भी कर चुका, ताकि इसका internal energy U2 तक बदला. Understand? So better you can see U2 is equal to U1 plus Q plus W. I mean to say U2 minus U1 is equal to Q plus W. Delta U is equal to Q plus W. Bas. Work is done on the system, positive. Work done by the system, negative. Heat is given on the system, positive. Heat is given by the system, negative. Bas. So this is what is called mathematical form of first law of thermodynamics. आगे बढ़ो. And here, yes. So let us apply for this isothermal process. Let us apply for isothermal process. Isothermal process में क्या होगा? dt is equal to 0. And the system is changed from V1 to V2. Okay, V1 to V2, so that pressure in the volume, you're going to get rectangular hyperbola as long as the temperature is constant, Boyle's law का हिसाब से. So it is from V1 and the V2. So V1 का volume कम and V2 का volume ज़्यादा है. So it is called expansion. So in this expansion, W is going to be negative. That's what I want to say. So positive, and equation Q, W is equal to Q. Right? And I mean to say, heat work is done by the system is equal to heat absorbed by the system. And the reverse and vice versa. You can say the process takes place slowly as the pressure on the piston reduces to gets expanded. And also the expansion tends to cool down, but the heat is reservoir is given here, heat is taken in. So it is called an isothermal process. Understand, something is written here, right? Similarly, isothermal compression reverse hoga. In this isothermal compression, you can see the direction of this. You can see the direction of this. Direction of the graph. If you understand this direction of the graph, you will understand actually question what it is asked. It is expansion and it is going to be compression. It is going to be compression. In this compression, W is going to be positive. Right, beta? W is going to be positive. Clear? And you can say adiabatic process. dq is going to be 0. When dq is going to be 0, delta U plus delta W is going to be 0. W is equal to minus delta U, or minus W is equal to plus delta U. It all here you can say, and you can say for this adiabatic process, PV to the power gamma is going to be constant. What is gamma? That is called Poisson's ratio between Cp and Cv. What is a Cp? Cp is molar heat capacity at constant pressure, Cv is called molar heat capacity at constant volume, and the P1 V1 to the power gamma is equal to P2 V2 to the power gamma. I want to say which of the following is true for the adiabatic process. PV to the power gamma is going to be constant. Mind it ख्याल में रखो, उसमें कुछ न्यूमेरिकल नहीं निकला. ओके अगर निकला हो तो you can do it. CP/CV ratio physics में है ना, and I'm going to get back to that also. And the adiabatic curve PV diagram is much steeper, we can say. I mean to say here P, V, and you are going to see isothermal, and it is going to be adiabatic. Adiabatic is much more steeper. Got it? Abhinav Yadav, hello, how are you? So you will be given A and B. Which of the following is true? It is going to be adiabatic हमेशा नीचे आने वाला है क्योंकि उसमें गामा पैरामीटर है. आइसोथर्मल में PV is equal to constant. Adiabatic में PV to the power gamma is equal to constant. Therefore, it is coming to the steeper in the version of the gamma parameter. So it's very important, and it is going to be useful even in the physics as well. And talking about here adiabatic process, we discussed this, right? Moving ahead, compression भी ऐसे आना चाहिए. Let us move into enthalpy kind of things. So what is enthalpy? What is internal energy? You can see. Let me just give you simple version of this. So U is called internal energy. Right? So in some books it is said to be A. U in the chemistry, I use it U because in the NCERT it is given as U. I wanted to say internal energy is the heat constant, heat of a system at a constant volume and sum of the all types of energies inside the system. Potential energy, चाहे इसको kinetic energy, rotational energy, vibrational energy, what not, all discovered types of energy forms are together inside the body. Inside the system is called internal energy. So this is actually calculated at a constant volume. But all the natural processes that are occurring in the nature is against to the atmospheric pressure. That is the reason why we need another term called as a enthalpy. So this is called enthalpy. So enthalpy is the heat at constant volume and constant pressure. So a new thermodynamic property has been introduced, that is state function. Internal energy is a state function and enthalpy is also a state function. Hi Maha, Abhinav, come on, let's see. So how do we define this enthalpy? अरे enthalpy and internal energy दोनों हमेशा थोड़े सा बराबर रहते हैं, लेकिन enthalpy is equal to internal energy plus some work. वो क्या फर्क पड़ता है? वर्क का मिला के इंटरनल एनर्जी एंथैल्पी को बराबर होगा. सो वर्क मीन्स व्हाट टाइप ऑफ वर्क वी डू. सो यू कैन नॉट कैलकुलेट. सो H is equal to U, we have PV work na, right? So at constant pressure वॉल्यूम कांस्टेंट होगा और प्रेशर कांस्टेंट होगा, प्रेशर कांस्टेंट होगा. सो लेट अस सी हियर change in the enthalpy is equal to change in the internal energy plus P delta V hoga, because the pressure is constant now. We know that PV is equal to N RT. P delta V is equal to delta N RT. So R is a constant at a given temperature, T is a constant. So that I just want to say delta H is equal to delta U plus delta N RT. ये खतरनाक फॉर्मूला है. ये फॉर्मूला का हिसाब से आपको एक क्वेश्चन आना है, ज़्यादा संभावना है. And Abhinav, Maha and Komal, Takboy and Betu, let us see how to handle this PV is equal to nRT application. And you guys says NEET examination में thermodynamics नहीं है, गैस स्टेट नहीं है, thermodynamics में है, लेकिन PV is equal to nRT गैस स्टेट में निकला, ये thermodynamics में इस्तेमाल करना है, right? So Maha, let us see delta H is equal to delta U plus delta nRT. So let us use these applications. Delta H is equal to delta U plus delta nRT. If delta H is going to be positive, that is going to be endothermic process. Mean to say heat is going in, and delta H is going to be negative, that is going to be exothermic process. That is going to be exothermic process, endothermic process and exothermic process. And अगर ये कुछ reaction को delta H 0 भी हो सकता, thermoneutral reactions. We have seen that delta H positive, delta H negative in thermochemical equations, how to calculate this. You can calculate delta H can be enthalpies of the react products minus sum of the enthalpy of the reactant. Total thermochemistry is relying on that. Maha, if you have any doubts based on this, how to calculate this? Always product minus reactant, ये याद रखना. एंड हमारा क्लास में आज चर्चा करना वाला है ये दोनों का अंतर क्या होगा. लेट अस से डेल्टा एन कैन बी जीरो, डेल्टा इफ डेल्टा एन इज इक्वल टू जीरो. व्हाट इज डेल्टा एन? मैं पहले ये बताना चाहता हूँ. क्वीन, कोमल, बेतु, डेल्टा एन आपको क्या बोलना चाहता हूँ यहाँ पर. डेल्टा एन इज दी delta n is the sum of the number of gaseous products minus sum of the number of gaseous reactant. Okay, this is the super awesome formula. Looking at this gaseous reactant or product, आपका 4 marks आने का आपको chance दे सकते हैं. Really it is a very good thing. Let us see Maha. If delta n is equal to 0, देखो कैसे. Let me give you. If delta n is equal to 0, so example, H2 is a gas plus I2 is a gas gives rise to HI is a gas. So delta n is equal to 2 minus 1 plus 1. You can say 2 minus 1 plus 1. 2 minus 1 plus 1 is equal to 0. It is going to be 0. So delta H is equal to delta U plus 0 RT. So delta H is equal to delta U. Any doubt? Students, let us see one more important thing. Let us change the color, you will understand. If delta n is equal to positive, आपको एक एग्जाम्पल देना चाहता हूँ. PCl5 in the gaseous state and it is going to give us PCl3 in the gaseous state and Cl2 in the gaseous state. How to use this? Here it is 1 and here it is going to be 1 and 1. So delta n is equal to, see the colors where you are going to get this. 1 plus 1 products minus 1 is going to be delta n is equal to positive 1. Delta n is equal to positive 1. Got it? A spontaneous reaction is exothermic reaction, may be exothermic or may be endothermic. Maha, you take melting of ice at room temperature is exothermic or endothermic? You tell me, Maha. Melting of ice at room temperature, endothermic or exothermic? It is supposed to be heat absorbing phenomenon, so it is endothermic. But nobody is asking to melt the ice, nobody is doing so. So melting of ice is a spontaneous process, hai na? Ha, yes. So you cannot say every exothermic reaction is a spontaneous reaction, right? Or every endothermic is a non-spontaneous reaction. A spontaneous or non-spontaneous बताने के लिए Usman, hi, want to say Gibbs free energy is another terminology is required. Okay, right? Right. It's talking about this delta H is greater than delta U. I want to take one more example here. Stay tuned. I want to give you Gibbs free energy change also. If delta N is negative, then example N2 plus 3H2 in the gas gives rise to NH3. Assume all are in the gas. So delta N is equal to 2 minus 1 plus 3 is going to be minus 2, right? It is going to be minus 2. Yadav boy. So delta H is less than delta U. And you will be given an equation, internal energy change will be given. You are going to ask to calculate the enthalpy, or enthalpy will be given to you. You will be asked to calculate internal energy change based on the equations that you know. The game changer and the key point to answer that type of questions, simply calculate delta n, can strike off the entire question and 4 marks will be in your account, right? Okay, no other discussions here. Yadav boy, please follow the class, no spamming here. Usman, right, it is going to be minus 2. Very good. Now let us move into entropy. Before going for this entropy, you are going to see the system over here. The particles, how it is arranged. Here the particles are arranged compact, right? And it is in the organized way. Those who are on online, please like the session. Maha, please, and other students, Yadav boy, please. Like the session. I want to see the like number during the class to increase the session energy. My dear students, here the particles are going to be random. यहाँ पर randomness ज़्यादा है, यहाँ पर randomness बहुत कम है. So randomness is a measurable parameter which decides the thermodynamics. So thermodynamics में ये randomness measure करने के लिए और एक state property चाहिए, that is called entropy. Okay. Entropy is a thermodynamic state function which measures the degree of randomness, organized, disorganized. How much disorganized is there? That is going to be given here. So enthalpy, entropy के दोनों का क्या अंतर मिलेगा आपको? So here, my dear children, let's see. Enthalpy is denoted by H and refers to the measure of total heat content in the thermodynamic system under constant pressure. यादव भाई और एक आधा घंटा चाहिए आपको क्लास डिग्री. Okay, so entropy is denoted by S, refers to the measure of the level of disorder in the thermodynamic system. Okay, so these are the variations of the enthalpy and entropy for your reference, and you can see second law of thermodynamics. So what second law of thermodynamics says? I want to say for first law of thermodynamics, I want to give a brief recapture. You are a new student. Okay, you please like the session, subscribe to the channel, so that what are the classes that is happening in every day, you will be getting an update, so that you will be no more a new student. For the previous lectures, you can watch the recordings bachcho, and you can do the best. ठीक है? And if you want any topic to be discussed in the class बेतु, you can mention in the chat box, so that अगले आना वाला का जो classes है ना, आपका explain करने का तैयार हूँ मैं. So first law of thermodynamics, it's a car. Okay, if you give 100 joules of heat energy, you are going to do 100 joules of work. You are going to do 100 joules of energy is given, 100 joules of work should be done. But it is not happening so. It is not happening so. You are doing less than 100 joules of work experimentally. Why? There may be heat loss. Assume there is no heat loss. Then also it is doing so. So that immediately second law of thermodynamics comes into the picture. Usman, yeah. What is happening? So the system cannot do unless a system cannot do work unless it has to increase the entropy. Entropy, some, let us say 5 joules, assume something like 5 joules. So unless some entropy is increased, it cannot perform its work. Therefore, I would say it is impossible to construct a 100% efficient engine. It is less than 100. So that itself is a second law of thermodynamics. There is a waste law, waste of energy. So if the bond is stronger than bond broken, then reaction will be exo endo. Maha, actually it all depends upon the type of reaction. Yeah, if the bond is stronger than the bond broken, so it is going to be endothermic process. Okay, and moving ahead, so it is important to know the second law of thermodynamics. It says it is impossible to construct a 100% efficient engine. Also you can say you cannot do work unless there is a increase in the entropy by compensation. So I want to say entropy of the universe always increases. So entropy of the system and surrounding is equal to entropy of the universe should be always greater than 0. That is only the it is taking place, so it is supposed to be positive. I mean to say thermodynamics में ये entropy calculate करें, d system is equal to dq reversible by time, temperature. So the d surrounding is going to be minus dq by temperature. अब जितना system dq by dt होगा and उतना ही है surrounding को जाना है. So it is going to be a loss in the entropy of the system is equal to gain in the entropy of the surrounding and vice versa. Okay, so you see this is the one. And first law of second law of thermodynamics, I wanted to say something over here. So if a system, this is a system 1 and this is a system 2. System 1 is at 0 degree centigrade. System 2 is at 25 degree centigrade. Okay. Uday Sai, yes, ds is equal to dq by t. Now I wanted to say iska thoda sa, I have given you 5 joules of heat, okay, and I have given you 5 joules of heat, dono ko. And I wanted to say here इसका डेल्टा एस ए and इसका डेल्टा एस ए डैश बन देगा. Initially it was at 0. So when you give 5 joules of heat, it is going to be SA dash. Okay. And what is the change in the entropy? Delta SA. Okay. Now, no, Maha, Usman, but I think so it will exo. No. When the bond is broken, energy is required. When the bond is formed, energy is released. Right? So the enthalpy of the reaction is equal to bond energy of the reactant minus bond energy of the product. That can give you the general version. Now you understand Maha? Hope the things are going fine. So let us say इसका initial जो SB है, SB डैश बन गया 5 जूल का एनर्जी दिया महा, राइट. सो ये दोनों का जो अंतर है ना, दैट इज कॉल्ड डेल्टा एस बी. मेरा सवाल है कि डेल्टा एस ए इज इक्वल टू डेल्टा एस बी, डेल्टा एस ए इज ग्रेटर देन डेल्टा एस बी, एंड डेल्टा एस ए is less than delta SB. So I want to give you only 3 options. I want to give you only, thank you, only 3 options. You tell me which is correct. You tell me which is correct. A, B, C options में कौन सा correct होगा? You like it? I wanted to say डेल्टा एस ए इज ग्रेटर देन डेल्टा एस बी, क्योंकि कम टेम्परेचर से ज़्यादा होगा. टेम्परेचर कम होगा तो एंट्रोपी इज गोइंग टू बी मोर ओवर देयर, माइंड इट. Increase in entropy from the lowest temperature is going to be more. So like that NEET examination आपका क्वेश्चन बहुत इंपॉर्टेंट होगा. सो यू कैन डू न्यूमेरिकल, उसमें कुछ न्यूमेरिकल नहीं है, सिर्फ मैथमेटिकल इंप्लीमेंटेशन है. यू से एज टेम्परेचर इंक्रीज एंट्रोपी इंक्रीजेस. इट इज गोइंग टू बी ए वेरी इंपॉर्टेंट थिंग. Now spontaneous process, the criteria of spontaneity. When you see a rolling stone down the hill, so don't stand like that because it is going to be so dangerous to you. So the rolling stone is coming down, nobody is going to do work. So this process is called a spontaneous process. The process which has a self urge to go by itself is called spontaneous process. And you say spontaneous process may takes place instantaneously or very slowly, doesn't matter. And non-spontaneous process hoga, so the reverse is not possible here. So the rolling of a rock uphill is a non-spontaneous process. You have to do work against to that. Samjhe? And you can see this is a spontaneous and this is a non-spontaneous. Uday Sai, no, I am not shouting, beta. I am not shouting. Don't worry, right? And I am giving you the lecture with a lot of impact. Take the impact. Okay, beta? And you can see this is a gas and this is a vacuum. Just open it. All the gas molecules are going to be spontaneous. Okay, beta? Right. You can take a system and the surroundings. You can say here change in internal change in entropy, delta S surrounding is equal to minus delta Q actual by T. And similarly you can say yes, this is what is called as the second law of thermodynamics. And here entropy change in the system plus entropy change in the surrounding should be greater than 0 for a non-spontaneous process. Actually spontaneity, non-spontaneity, ये बोलने के लिए आपका Gibbs free energy चाहिए. What is this Gibbs free energy? So let us moving into that. Sadi-Carnot cycle, we'll discuss it here. Second law statement is also given and entropy calculations for the various processes, and we'll do criteria of spontaneity. Time is very less ना, so मैं थोड़ा सा आगे बढ़ना चाहता हूँ. And we can say what is the criteria of spontaneity? 2 things are required to make a spontaneity. A system always wanted to be in the lowest energy state, to that it is going to have the more stability, right? and system always wanted to be more randomized, so that I wanted to say it has to be at the lowest possible energy, means it should lose the energy. It should be delta H is supposed to be negative, and it wanted to be more randomized, entropy should be increased, and I want a tendency to have the minimum energy and a tendency to have a maximum randomness, and these two are together is given as Gibbs free energy change. So this Gibbs free energy change tells you the criteria of spontaneity. Like this is a Gibbs free energy change, it is actually the measure the capacity to do the useful work. The actual energy content that is given to the system is used for the work, and the work given to the system is categorized into two versions. One is used for the work, one is not used for the work. If it is not used for the work, it is going to be entropy change. That is, yes. So that is given as the system whose energy decreased is actually useful for the work done is called Gibbs free energy change. So relation between G, H, T, S is given as G is equal to H minus Ts. That is delta G is equal to delta H minus T delta S. This is called as Gibbs free energy change. So just like a Newton laws. Now what you are copying, Uday Sai? Uday sir, Gibbs free energy and Gibbs free energy change. Okay. Here it is going to be a delta G is equal to delta H minus T delta S. It all depends upon the type of process, and I want to say if the system is spontaneous, delta G is supposed to be negative. If the system is non-spontaneous, the process is non-spontaneous, delta G is going to be positive, and if it is at equilibrium, it is going to be 0. So in this delta G is equal to delta H minus T delta S, what delta G talks about? Change in Gibbs free energy, and delta H talks about change in enthalpy, and T is the temperature, and S is the change in entropy. Okay, dear children, Uday Sai, you wanted to say something I can't actually understand, please don't spam it. Okay, Maha, fine. Let us see here. So effect of temperature on spontaneity. So I wanted to say for this process, we know that delta H is equal to delta G is equal to delta H minus T delta S. Okay, if delta G is equal to 0, equilibrium. If delta G is less than 0, that is spontaneous, and delta G is positive, it is going to be non-spontaneous. Dear children, from now onwards in the total physical chemistry carry this. So in that delta H delta S, if delta S is positive, delta H is negative. Delta G is going to be negative at all temperatures. Therefore, I would say the process is going to be spontaneous in all temperatures. Yadav. Let us see the reverse. Delta H is positive, delta S is negative. If you put these values in this Gibbs-Helmholtz equation, delta G is going to be positive at all temperatures. Such type of reactions never and ever happens. So such processes are all non-spontaneous at any temperature. Yes, Usman, if the delta H is negative and delta S is negative, now you can say it is going to be delta S is negative means exothermic. So such processes are going to be spontaneous at low temperature and non-spontaneous at high temperature, and reverse it. So like this, based on this table, I would say, so for 2-3 times in the medical entrance examination and other entrance examinations, so many questions has been asked. Sometimes at what temperature the process can be spontaneous can also be given into the questions. So stay tuned, such type of questions we will be discussing in a special class, so I want to take all the concepts as a numerical part and I want to conduct a new session for that. So आज का क्लास में हम सिर्फ कॉन्सेप्ट डिस्कस किया. Maha, hope you like this session. Those who are online, please like this session. And Usman and Betu and Sai, right, Yadav boy. And I'm done from my side for today, and we'll be discussing the session with more and more number of numericals in the next upcoming session. Thank you very much. Thank you. If you have any doubts, and watch the recording and put it in the comment box. And I'm done from my side, signing off. Suresh, Faculty of Chemistry from Infinity Land. Thank you. Bye bye.